This is video 2D for the Year 10 Mathematics course. In this video, we're going to cover the theory behind factorising expressions with four terms, under the topic of algebraic expansion and factorisation. Specifically, we're going to explore how to factorise expressions with four terms, factorising a negative from a bracket, and then we're going to cover some example questions. In our previous video, we explored and introduced something called bracket factorisation, which effectively is the idea of when you have multiple terms that have the same bracket in each one, and you can actually use that as a highest common factor. So just as a quick example, if we had x multiplied by x minus 7 plus 3 multiplied by x minus 7, we can see that between this term and this term, then a common factor of both terms is the bracket of x minus 7. So what that therefore means is we can actually pull this common factor out to the front. So we can write x minus 7 out the front. Then we can open up a second bracket and effectively write in whatever we have left over. Because with this first term, if we get rid of this x minus 7, we're just left with x. And then with the second term, if we get rid of the x minus 7, we're left with plus 3. So the factorised form of this original expression was x minus 7 multiplied by x plus 3. With what we're about to go through in today's video, this is going to be a quintessential part of the process, because understanding how we can use brackets as a highest common factor is a really important thing, actually throughout the next couple of videos that we're going to be looking at. So if you need to have a refresher about this stuff here, now is a very good time to do it before we delve into the next couple factorisation techniques. Now, what we're going to be delving into in today's video is something a little bit different. We're going to be dealing with situations where we have an expression that has four terms. But the most important thing here is that all four terms do not have a common factor. And as an example of something like this, let's say we had x squared plus 3x minus 7x minus 21. And what we can see here is that all four of these terms do not have any common factors between them. So what are we actually meant to do in this kind of situation? Because what this does is it limits our ability to use just basic factorization because we don't have any common factors. So what we need to do in situations like this is we need to factorize in pairs. So what do we mean exactly when we say factorize in pairs? Well, let's actually use this expression up here. We've got x squared plus 3x minus 7x minus 21. What we're going to do is we're actually going to group pairs of terms from this expression. We're going to consider the first two terms as a pair and then the last two terms as a pair. And what you then do here is we factorize each pair individually. So let's consider the first two terms, x squared and 3x. The only common factor here is an x, so then we can write this as x multiplied by x plus 3. Then with the second pair, the highest common factor is a negative 7, and then if we pull that out to the front, we're then left with x plus 3 in a bracket. You know that you've done the right thing in this case if this bracket and this bracket are the same. Because now what we've effectively got here, if I just write this part over here again, x multiplied by x plus 3 takes 7 multiplied by x plus 3. What we've now got here is just a situation in which we can factorize brackets, which is exactly what we started this video talking about and what we covered in our last factorization video as well. Because here we've got this and this as a common factor, so we can rewrite this as x plus 3 out the front, open up a second bracket, and then we can just write out whatever we have left over, which in this case is x minus 7. So this thing here is the fully factorized form of this original expression here that had 4 terms with no common factors. So let's write out a bit of a step-by-step process that we can use to factorize expressions with 4 terms. So our first step was to group the terms that we have in our expression into pairs. Now, just as a quick disclaimer about this part here as well, you can actually rewrite the expression in any order that you want to. So if I take this example up here again, if you really wanted to, you could rewrite this then as x squared minus 7x plus 3x minus 21. Then you could group this pair and this pair together, and as it turns out, you'll get the exact same result either way. It just means that the interluding factorizations that you do may just be a little bit different. But overall, you can actually rewrite that expression however you wish to. It just depends on what order you would rather factorize these terms in, just to make it a bit easier for yourself. But in any case, you should still get the exact same results. So I'll write this here in that you can reorder the terms however you wish. Then step number 2 is to factorize the 2 pairs of terms that you have. Step number 3, at this point here, hopefully what you should have then is 2 different terms that have the exact same bracket present in each one. So in other words, we then need to identify the common bracket. Now, just as a quick reminder as well of something that will become very, very helpful that we explored very briefly in our previous video, is that if you need to, you can use this rule here, that if you have a bracket called a plus b, then this here is equivalent to negative a minus b. In other words, if you pull a negative out the front of a bracket, then the effect that has on everything on the inside is a changing of signs. So in other words, you can absolutely change the sign of the overall bracket to make it negative or positive or whatever, but in doing so, you then need to change the signs of everything inside of the bracket itself. That there is going to be particularly helpful when the 2 brackets that you have in this step look very, very similar, but the signs are just different. So do keep this rule here in mind, but we would have practiced that quite a bit in our last chapter, so hopefully it's nothing too new at this point in time. And then our 4th and final step in this overall process is just to perform the standard bracket factorization. But in my solemn opinion, I don't think this process is overall too bad, because realistically, it's just combining 2 different types of factorizations. In step number 2, we're using basic factorization, and then in step number 4, we're using bracket factorization. So instead of just using one or the other, we're actually now going to be using a process that implements both types of factorizations. It is definitely something that comes with practice, so please make sure you're practicing this part here in particular, because this overall process is going to actually come back in 2 videos' time in a very, very, very important way that will then transfer into year 11 and year 12 as well. So overall, this process, whilst it is reasonably straightforward, it's a very important one to make sure you understand how to do flawlessly. Now, with that being said, let's go through a few different types of examples of how we can factorize expressions with 4 terms. Alrighty, so the first example that we're going to consider is the expression of xy plus 6 plus 2y plus 3x. Now, hopefully what you should immediately notice about this one here is that if I decided to group the terms with this pairing and this pairing, in both situations there is actually no common factor. So what that therefore means is that we're going to have to first of all reorder these terms in a way that we can actually factorize. So the best way that we can go about doing this is I'm just going to rewrite this as xy plus 2y plus 6 plus 3x. And then we can group this pair of terms and this pair of terms and factorize from there. If we consider the first pairing, xy plus 2y, the highest common factor is y, so we'll pull that one out to the front. Then what we have left is x plus 2. From the second pairing, the highest common factor is 3, and then what we're left with is 2 plus x. We know that we've done everything correctly because this bracket is the exact same as this bracket here, which means that we can then pull that common bracket out to the very front. So we're going to put x plus 2 out the front, and then we're going to open up a second bracket, and now we can just write in whatever we have left over, which in this case is y plus 3. And so therefore, our fully factorized form is x plus 2 multiplied by y plus 3. The second example that we're going to consider is a squared plus 5a plus 2a plus 10. So in order to factorize this, I'm first of all going to group this pair of terms and this pair of terms. With the first pair, the highest common factor is going to be a. So by pulling out that common factor, we're then left with a plus 5. Then with the second pairing, the highest common factor is 2, and then we're left with a plus 5. Once again, we know that we're on the right track since this bracket and this bracket are the same. So now we can pull this common bracket out to the very front, a plus 5, open up a second bracket, and now we can write in whatever we have left over, which in this case is a plus 2. And so therefore, our fully factorized form is a plus 5 multiplied by a plus 2. The third example we're going to consider is x squared plus 6 minus 3x minus 2x. Now, similar to our very first example, the first thing that we should notice here is that if I group together this pair of terms, then we do not actually have anything in common between these two. So it means, therefore, that we're going to have to first of all reorder these terms in a way that we can group them with common factors. One of the ways that we can do this is I'm going to rewrite this as x squared minus 3x plus 6 minus 2x. And so now we can group this pair of terms and this pair of terms. From the first pairing, the highest common factor is x, and then in the bracket, what we'll have left is x minus 3. From the second pairing, the highest common factor is 2, and then what we're left with is 3 minus x. Now, what we should notice about this bracket and this bracket is that they look very, very similar, but they are not exactly identical. In the first bracket, it's positive x and negative 3. In the second one, it's positive 3 and negative x. So the way that we're going to compensate for this is we're going to write the first term exactly as it is. We're going to pull a negative to the front of the second bracket. That will then make it negative 2. And then to compensate, we need to change the sign of everything inside of this bracket. So instead of it being negative x, it's now going to be positive x. Instead of it being positive 3, it's now going to be negative 3. This is really good for us because now we can see that this bracket and this bracket match up exactly. So we can pull that out to the front as our highest common factor. And then in the second bracket, we can just write in whatever we have left over, which in this case is x minus 2. And so therefore, the fully factorized form of this expression is x minus 3 multiplied by x minus 2. And then our fourth and final example that we're going to consider is the expression of 2x squared minus 6x minus 3 plus x. Now, for this particular situation, I am going to start by reordering the terms purely because these two back-end terms do not actually have anything in common. So the best way that we can reorder this is by writing it as 2x squared plus x minus 6x minus 3. And so now we can group the terms into this pair and this pair. From the first pair, the highest common factor is x, and then in the bracket we'll have 2x plus 1. From the second pairing, the highest common factor is negative 3, and so then what we're left with is 2x plus 1 inside of a bracket. We know that we've done everything well because this bracket and this bracket match up, so we can pull that common bracket out to the very front. So we've got 2x plus 1, open up a secondary bracket, and now we can just write in whatever we have left over, which in this case is x minus 3. And so therefore, the fully factorized version of this expression is 2x plus 1 multiplied by x minus 3. Alrighty, let's summarize what we've learnt today. So in this video, we revised bracket factorization, which is where multiple terms have a common bracket as a factor, which we can then proceed to factorize. That is, c multiplied by a plus b plus d multiplied by a plus b is equal to a plus b multiplied by c plus d. We then applied this technique to expressions with 4 terms, in which we first group the terms in pairs, where each pair has a common factor. We then factorize the common factorized bracket in each pair. For example, if we consider AC plus BC plus AD plus BD, we can first of all pair AC and BC, and then AD and BD. Factorising each of these pairs, we get C multiplied by A plus B, plus D multiplied by A plus B, and then factorising the common bracket factor, we then arrive at A plus B multiplied by C plus D. We then applied this process to some example questions. And that's it for now. See you in the next video.